The COVID crisis posed a big challenge on manufacturers, asking for more medical devices, such as massive production of face masks. This has ended up with consequent requests for higher flexibility and fast response in production, and obviously on-training needs to optimize the use of such devices or equipments. Manufacturing Setting 6 responds to these criticalities by setting a reconfigurable mask production equipment. In this video we explain how the technical manuals and the 3D model created for the complex equipment have been used to build an augmented virtual reality training tool to support the users on the best use of it. The Space One platform is a leading solution for extended reality technologies that support the use of AI, and has been used for the development of advanced training and remote collaboration. To demonstrate the support to junior technicians during maintenance, facilitating the collaboration and knowledge sharing, even remotely. The first screen shows the main menu, where the training tasks are managed with defined work orders. The 3D model of the mask machine has been imported and split in an asset hierarchy, so different components can be searched and related manual items presented. Knowledge repository keeps all multimedia information that could be shared among the different operators. Finally, the extended collaboration option enabled different users to set up a remote session where the senior workers support the junior ones. The user has to define which device will use. It could be a tablet, a smartphone, or even a VR head-mounted display, driven by voice commands. We will use the VR device later on in the demo. Work orders, so training tasks are assigned to the user. Here we can choose between training for MS4 and MS6. We will select the training procedure related to the reconfigurable mask production machine. Here we have a description of the activity to carry out on the left, in our case the maintenance procedure, while a 3D model of the asset involved in the activity is shown on the right. From the menu below we can select documents, thus showing documents related to the specific activity. From the main window we can decide to step ahead with the training procedure clicking on Confirm. In case of need the user can move to the next or the previous step clicking on the related buttons. The window on the right can be selected and a higher level of detail can be shown. We can view or hide different components of the 3D model. Each operation has its own highlighted components. There is a way to interact with the 3D model, zooming and panning the mask machine, and showing the 3D model in wireframe or rendered mode. Stepping ahead in the training procedure, different components can be displayed in high detail. Following the various training steps, some components are highlighted in the 3D model, in this example the shaft 2, in order to guide the user. In the following operation the shaft 3 has been highlighted, and here the roll should be placed on with the third layer material. Next steps is on shaft 4. From the menu below, clicking on Documents displays the mask machine operator manual, which can provide useful information on the activities. Selecting images, some more details on specific components could be showcased, helping the user in the procedure. Here this picture helps the user to realize that the unwinding should be counterclockwise. Moving back to the training procedure, in the 3D model visualization, a submenu enables the selection and further analysis of specific components. For example, here we could select the pneumatic switch panel. From the top menu we can also select the knowledge repository and consult it for useful contents, for example images, videos, documents or other annotations related to the procedure can be checked. Here we can watch some shared videos, such as the rendering of the overall machine with the gaming engine developed by SME in order to support employees of future adopters of this equipment. This is the virtual reality implementation of the training session, with the user immersed in a virtual scene. In this case, we have hand gestures using a pair of controllers. Regarding the location in the virtual scene, we have a teleport function to move inside the scene. The green spot represents the movement in space. The video previously shown in a tablet now is virtual, and displays the list of instructions to perform according with the maintenance procedure. The actions of pick and move or rotate or push buttons are performed through the controllers. As in previous demo, images and videos are available and help the user in the maintenance activities. As in previous demo, some components of the assets are highlighted to guide the user in the specific activities. The tablet now lists the sequence of operations of the maintenance procedure. The user selects the first step, which is turn on a valve, then starts doing it with the help of the associated images shown in the virtual tablet in the background. Then the second step, asking for switch down. Now the user selects the third activity, close the clamps, and moves close to the equipment to do it. For this he needs to move forward to open the highlighted door of the C module. Once opened the door, the user can view the inside of the asset with all of its components, again, with the guidance of the pictures shown in the tablet in the background. Then the user starts the last step in the procedure, asking for shifting up the cylinder. So he moves closer to the equipment, grab the cylinder and shift up. Here we can see that the user can move objects and interact with them virtually. Then the user needs to close the door of the C module, highlighted here. Finally, the user inspects the equipment, and the training section has been completed. No errors have been traced. So, to summarize, extended reality technologies have demonstrated to be an effective support for the advanced training, remote collaboration and knowledge sharing activities, which are key elements to be leveraged in case of crisis such as pandemics. In this case, virtual reality capabilities can be more relevant in case of 4D situations, meaning dull, dirty, difficult or dangerous, for the user. Here the cloud is a technology that can boost the impact of such solutions, collecting and making available advanced applications, contents and knowledge everywhere on Earth. In the Covercital project, the digital technopole is based on cloud and acts as an hub that provides all this expertise, and collect all lesson learnt and join forces against COVID.